Hello. So in today's lecture, we're going to be looking at some of the exercises from chapter 1 on Python programming. So we won't be going through all of them today, but all of the solutions will be available on the course webpage. So let's start with exercise 2. So for exercise 2, we need to write a Python program that accepts a sequence of comma-separated numbers from the user and generates a list of those numbers. Okay, so this is an important exercise because we're going to be dealing with a lot of comma-separated data. So it won't always be inputted by the user. For some of the problems, it will be from a file, but we need to know how to convert this text formatted data into a list of numbers that we can then use. Okay, so let's have a look at the solution. So first of all, we need to get the string from the user. So we use the input function with a prompt, comma separated number list, just to tell the user what to enter. So this input function or input method will return a string. So we've got that here, number list underscore str, just to say that it's a string. And we need to turn the string into a list of numbers. So one way of doing that is to use a list comprehension. So what we do is we go through all the elements of the string that have been split on the comma. Okay, so wherever there is a comma, those elements there will get split up into a list of substrings. Okay, however, that is a list of substrings. We want the numbers. So for each element in that list of substrings, we need to use the typecasting float to convert the string into a float. Okay, so that's just to be on the safe side. We don't know if the numbers are going to be integers or floats. However, integers are contained in floats, so it's better to be safe and convert it to a float. Okay, so now we've got a number list, so a list of the numbers as floats rather than as strings, and then we can just print out the number list. Okay, so other exercises will ask us to then do things with that list of numbers, but just this one is to convert it into the list of numbers. Okay, let's have a look at the next one. Exercise 4. So write a Python program to calculate the number of days between two dates. The input should be day, month, year for the first date, followed by day, month, year for the second date. Okay, so if we have this date here, day, month, year, and this date here, again, day, month, year, then there are 9 days in between those. Okay, we need to calculate that. Okay, so let's have a look at the solution. So for the first date, here we have date one, date one for day, month, and year. And these are inputted, okay, by the user, and those are inputted as strings. However, for day, month, and year, we want to work with integers instead. So we use the int typecasting function to convert the string that's inputted by the user into an integer that we can do maths with. Okay, so we have day, month, year for date 1, day, month, year for date 2, and now we can start calculating the difference between the two dates. So since we want to calculate the difference being in days, one way to do this is to convert the first date, so day, month, year, into some number of days, convert the second date into some number of days, and then find the difference in days. Sorry, there's a typo here. That should be date 2. Okay, so this is for the second date. So date 2, and date 2. Okay, so just on that note, the reason I got that error is because I just copied and pasted the code, which is not the best to do. So just a bit of advice. If you are going to copy and paste bits of code, check to see that you have made all the necessary changes. So as you saw here, I copied and pasted, but I didn't change the 1 into a 2. Okay, so very common mistake. Please be aware of that. Okay, so number of days for date 1. So how do we work that out? Well, we take the number of years that it's been times 365 and then add how many days it's been. Okay, so this is our starting off how many days there are. Now, onto this value, we need to add how many days there are for the given month. So if we are at the end of Jan, for example, let's say at the end of Feb, then you've got 28 days for Feb, not including leap years yet. But then we also have the 31 days of Jan that need to be added on. Okay, so what we need to do is go through all the months that have occurred prior to the current month and add those days. So here we're going from month 0, that's being January, because we start counting from 0, up to the previous month. And for each of those months, we add however many days that has been. Okay, and then after that, we need to consider any leap years. So we set the number of years to be the current year. Then if the current month is less than or equal to 2, then we need to subtract 1. Yeah, that's because Feb is the second month. So if we are after Feb, then we need to see if there is a leap day that we need to add on. Okay, how do we check that? Well, we use the definition for a leap year. So a year is a leap year if, number 1, the year is a multiple of 400. Number 2, the year is a multiple of 4 and not 100. Okay, so you can look this up. This is the definition for a leap year. Okay, so with this in mind, we can calculate how many leap years there are by taking the number of years, dividing by 4. Remember to take the integer part. Then the number of minus the number of years divided by 100. Okay, take the integer part because it's not 100, so we need to minus that. And then we add the number of years divided by 400. That will give you how many leap years there's been. And we know for each leap year, we need to add 1 more day. So the total number of days so far, we need to add the number of leap years. Okay, so that's 1 day per leap year. So that is the process to find the number of days for the first date. We do exactly the same thing for the number of days for the second date. So you see everything is exactly the same here. And then the days difference is going to be the number of days for the second date minus the number of days for the first date. Okay, and then that will give you the number of days difference between the two. Okay, so it's not too difficult. It's just about keeping track of where these days are coming from. So each month has a different number of days, and the years will also provide a different number of days if the year is a leap year or not. So you need to take that into account. Yeah, but if you just follow that, it's quite simple. Okay, let's have a look at the next exercise, exercise 6. So write a Python program to calculate the difference between a given number, so that's a number from the user, and 17. If the number is greater than 17, return twice the absolute value. Okay, so let's have a look at that. So we need to get a number from the user. So we use input and then a little prompt to tell the user what to input. Now remember, input will return a string. We can use the float typecasting function to convert the number into a float. Okay, once we have the number, we can calculate the difference between 17 and that number. Okay, that gives us the difference. Then if the number is greater than 15, so that means we execute this part of the code, we print twice the absolute value. Okay, so ABS, that is short for the absolute value. Okay, so twice the absolute value of the difference. Okay, if this condition is not satisfied, then we don't get any output. Okay, let's have a look at exercise 8. Write a Python program to test whether a passed letter is a vowel or not. Okay, so that doesn't seem too bad. So what we can do is create a list of the vowels. So A, E, I, O, U, like that. we can input a character. So you have input the character. Here are typecast to a string, but that's not needed because remember, input already gives a string. So for those other exercises where we typecasted to a float or integer, there we had to do typecasting. Here you can, but it is not necessary. So we can remove this redundant part here. Okay, so let's make a note. Input already returns a string. So we do not need to typecast to a string. Okay, so it doesn't hurt, but it is redundant. Okay, however, if we are working with floats or integers or booleans or anything else like that, then we do need to typecast. Okay, so I just made a note here. So here we had vowels list, where we've listed each individual character. So that's one way to do it. And then we can check if character is in the particular list. So here I'm just putting the string A, E, I, O, U, but we know that strings are just lists of characters. So let's make a note here. We can either use the string A, E, I, O, U, or we can use the list as we defined above there, A, E, I, O, and U. Okay, so that's just a little note on that. So strings are lists of characters. So you can either explicitly write out a list of characters, or you could just use the string itself. Okay, both are acceptable. Okay, and then this in keyword, that just checks if this thing on the left-hand side is in this thing on the right-hand side. So is that object contained in that list or string? Okay, but again, a string is just a list of characters, so you can view it as a list. Okay, so if the character is in this list, then it must be a vowel. If it is not in the list, then it is not a vowel. Okay. And then I made the note here as well. We could also use vowel list A, E, I, O, U, since the string is already a list of characters. So over here, we can replace this with vowels list, and that will have the same effect. Okay, let's have a look at the next exercise, exercise 9. Okay, so write a Python program that will accept the base and height of a triangle and compute its area. Okay, so very straightforward. We can get the base from the user with the input function, remember to typecast it, and that gives us the base. We can input the height, remember to typecast it, and we can call that the height. Then the area is half base times height, so we can just say 0.5 times base times height. So just a note on that. We could also use base times height and then divide by 2. Okay, so you can use 1 multiplication and then divide by 2, or you can multiply by a half. Yeah, it does exactly the same thing. And then we can just print the results back to the user. Okay, let's have a look at exercise 10. So write a Python program that computes the greatest common divisor of 2 positive integers. So we need to look at the factors of the first integer, factors of the second, and pick the largest common one between the 2 lists. Okay, so how do we do that? Well, we can get number 1 from the user. Remember to typecast to an integer. We can get number 2 from the user, again, typecasting to an integer. So what we need to do is exactly what I said. We go through all the factors that are common between the both of them and get the largest one. So we start off with a GCD of 1, because 1 is a factor that goes into both numbers, but it may not be the largest one. So what we do is we create a for loop that goes from 2, which is the next possible factor, up to the minimum of the two numbers. Okay, why the minimum of the two? Well, because if number 2 is greater than number 1, it's no use looking for factors that are bigger than number 1, because it wouldn't be a factor of number 1. Okay, so we look up to the smaller of the two. Okay, and then we need to add 1 here, because remember, the range method does not include the upper bound. So if we want this upper bound here to be included, we need to add 1. Yes, that takes care of the for loop. Now we need to make sure that this n that we're looping through is a factor of the first one. In other words, the modulus is 0. If it's a factor of the second one, modulus again is 0. If both of these are true, then that means that number is a factor of both of them. And so we set the GCD to be that number. If we go through all the possible factors, then at the end of the for loop, the GCD will then be the largest of all those factors. Yeah, and then we can just print the GCD. Yeah, let's have a look at exercise 12. Write a Python program to sum two given integers. However, if the sum is between 15 and 20, return 20. Okay, so that's a bit of work on if statements. So let's have a look at that. So exactly the same as before, we got number 1, integer typecasted of what the user inputted. Same thing for number 2. We set the sum to be number 1 plus number 2. If sum is greater than or equal to 15, so that's this first part, and the sum is less than or equal to 20, that's the second part, then we print 20. Otherwise, we print the sum. Okay, so that's what this if and else does. So if it's within this range, print 20. If it's not within that range, print the sum. Okay, so we're just converting the English sentence with if and then and else and all that to program syntax. Okay, let's have a look at exercise 15. Okay, so exercise 15, write a Python program to calculate the distance between the points x1, y1 and x2, y2. So we've got 2 points in 2D Euclidean space, and we're trying to find the distance. So we can just use the distance formula, but we need to convert the distance formula into Python syntax. Okay, so the first thing we need to do is import the math module, because we need to use the square root. Okay, so that's in the math module, or we could use the NumPy math module as NP, and then we can use NP dot square root. If we use the math module, then we can use math dot square root. Okay, so it's up to you which one to use. However, we'll see later on when we do the linear algebra part that this NumPy module has linear algebra functions that the math module doesn't have. Okay, so I would rather you use the NumPy module for now, so that it's not too foreign when we get to it later on. Okay, so let's get all of the values. So we get x1, y1, x2, y2 from the user. Remember to typecast to a float, because it may not be integers. So we could input some decimal number. Then we calculate the difference in x, so x1 minus x2. We calculate the difference in y, y1 minus y2. And then the distance is going to be the square root of the difference in x squared plus the difference in y squared. So here I just have delta times delta. That gives us delta squared, but we could also have delta x double star 2. Remember, that's exponentiation by 2 plus delta y double star 2. Again, that's exponentiation by 2. Either way, that's fine. And then we can just print out the distance. Okay, let's have a look at exercise 16. Yeah, write a Python program that converts seconds into days, hours, minutes, and seconds. So here we have a whole lot of seconds, and we need to figure out how many days, hours, minutes, and seconds can be extracted from the total number of seconds. Okay, so let's have a look at that. Okay, so I've just got a note here. We get the total seconds as an integer typecasted from whatever the user typed in. And then a note here. So there are 60 seconds in a minute, 60 times 60 seconds in an hour, 60 times 60 times 24 seconds in a day. So that's going to help us convert between total seconds and then those individual amounts. Okay, so the number of days will be the total amount of seconds divided by how many seconds there are in a day. Okay, very simple division there. But note we're using integer division because we want whole number of days. Okay, so then the remaining seconds will be the remainder after division. So that will be the modulus. Same thing for the hours. We take the remaining seconds divided by the number of seconds in an hour. That gives us the number of hours. And then the remainder after the division, that will be the remaining seconds. Okay, and then once we have that, we can then divide by 60 to get the minutes. And then the remainder after division will be the remaining seconds. So we can then output how many days, hours, minutes there are, and then whatever's left over after the final division for minutes, that will be the remaining seconds. Okay, so that's how we can get those values. Okay, so we just divide by how many seconds there are in that unit of time, and then whatever's left over, we can then divide by the next biggest units of time. Okay, not so bad. Let's have a look at exercise 17. Write a Python program to calculate the sum of the digits of a number. Okay, so let's have a look at that. Okay, so we get the number as an integer because we're looking at the digits, so the tens, hundreds, thousands, so on. So we get our number as an integer from the user. We set the current sum to be 0, and then we use this while loop. So let me explain how that works. We have sum plus equals, so we're adding onto the sum number mod 10. So what mod 10 does is it gives us the rightmost digits. So for example, 19 mod 10 will give us 9, 101 mod 10 will give us 1, 27 mod 10 will give us 7. In all those cases, it gives us the rightmost digits. So we take the sum and we add that digit. Then we use this integer division by 10 to get rid of that digit. For example, if we look at that 27 case, 27 mod 10 will give us 7, which is that rightmost digit. And then 27 truncate divide by 10, or integer division by 10, that will give us 2.7. But remember, it's integer division, so we just left with the 2. So the mod 10 gives us the first digit, divide by 10, integer divide by 10, that gives us the next digit. And then the 7 plus the 2, we can add that up to get the sum of the digits. Okay, but this is for a 2-digit number. For a number with many more digits, we simply repeat this process. So if we look at 121, for example, we're going to get 1. And then if we truncate divide by 10, we're going to get 12. That's going to give us 2 left over, and then we're left with 1, and then that gives us the 1 digit. Okay, following that process. And then we can simply sum up along the way. So 1 plus 2, that will be 3, plus 1, that will be 4. So at the end of the while loop, the sum will be the sum of the digits. Yeah, and then we just say while number is greater than 0. In other words, while there is still digits to be taken care of. Okay, let's look at the next exercise, exercise 22. Okay, write a Python function to find the maximum and minimum numbers from a list of numbers. The return should be minimum, comma, maximum. Okay, so let's have a look at that. So we begin by importing numpy as np. So this is one way of finding the minimum and the maximum. We start off by setting the minimum to be infinity. So np.inf, that's infinity, and the maximum to be minus infinity. Okay, so that might seem a bit odd, but let's just follow on. For number in number list, so for each number in the list we provided, if the number is greater than the maximum, then replace the maximum with that number. But here we set the maximum to be minus infinity. So any number we come across will be bigger than minus infinity, so it replaces the maximum. If we then come across a larger number later on, then that will replace the maximum. And we can continue that for all the numbers in the list. Similarly, for the minimum, if the number is less than the minimum, remember we set the minimum to infinity, so any number will be less than infinity. So that number will then replace the current minimum. And then if we find anything smaller than that one, then again, it gets replaced. Okay, and then this process can continue. Once we go through all the numbers in the list, then we will have our maximum and our minimum. And then we can just return minimum and maximum. Okay, so just a note on what this object is. If you have open brackets, some number of elements separated by commas, and then a closed bracket, we call that a tuple. So it is very similar to a list. Okay, we can read from it with indexing, just like a list. However, we cannot write to it. So once the tuple is created, it becomes read-only. Okay. So this is called a tuple. It's a read-only list. Yeah. So we will be seeing this later on when we work with coordinates, because we can have x, y, z. Once a point is made, you're not going to change that point. So we can set it as a tuple of x, y, z. Okay. However, you can use a list of x, y, z. That's perfectly fine. But then remember, the list can be modified. So maybe you don't want it modified, so then you would use a tuple instead. Okay, but we will go through that later on. Just a note here with this infinity and minus infinity, if you don't like that way, you could set it to number list 0, number list 0. So we just set it to the first element that we find, and then we continue the process. If anything is bigger than the first element, then it replaces the maximum. If anything is smaller than the first element, then it replaces the minimum. Okay, so then that's exactly the same process. Okay, so you can use either one, you will get the same outcome at the end. Okay, let's look at exercise 23. Okay, write a Python function that takes a positive integer and returns the sum of the cubes of all positive integers smaller than that number. So if we had the number 9, then we would return the sum 1 cubed plus 2 cubed plus 3 cubed all the way up to 9 cubed. Yeah. Smaller than that number, sorry. So we don't include 9. So it will go up to 8 cubed. Okay, so smaller than, we take that to be strictly smaller than. Okay, so we define a function using the keyword def or define. We got the name of the function and then the input being the number. Okay, so we can start off by initializing the sum to be 0. Then for num, that's just a placeholder variable, from 1 up to that number. So here the upper bound is number, but remember for the range function, this upper bound is not included. So it goes from 1, 2, 3, 4 up to and including number minus 1, okay, not number. And then we just have sum, and we increment it by number times number times number, num times num times num, so that's num cubed. Another way to do this is just to have num double star 3, so that means exponentiation by 3, or just cubing. Okay, so either way, we get the same answer. Okay, maybe this one is a bit clearer that we just want it cubed. And then once that's all done, we just return the sum, and then that will get sent back to wherever you called the function from. Okay, let's have a look at exercise 24. So write a Python function that will return the sum of the factors of the given number. So given a particular number, we need to go through all the numbers smaller than it, check that it's a factor, and then add it to an average. Sorry, not an average, a sum. Okay, so 24. So sum of factors, number. Again, we've got the sum initialized to 0. Then we go through all the factors. So we start from 1 and we go up to number plus 1. So remember, we have to add the plus 1 for this to be included. So if you want number to be included in your for loop, you need to add 1. If you don't put the plus 1, then that upper bound is not included. Okay, how do we check if it's a factor? Well, number mod num is 0. That means there is 0 after division, which means this num is a factor of number. So since it's a factor, we can add it to the sum. That will give us a running total, and then we can then return the sum. Okay, pretty straightforward. And finally, exercise 25. Write a Python function that will print the first n Fibonacci numbers. Okay, so remember how the Fibonacci numbers are defined. The next Fibonacci number is the sum of the previous 2 Fibonacci numbers. Okay, so we need to keep that definition in mind. Okay, so let's have a look at that. Okay, so here I've illustrated 2 ways here. So the first way uses a list to keep track of all the numbers. So we initialize the list with 0, 1. So the first Fibonacci number is 0. The second Fibonacci number is 1. So we have the first 2 Fibonacci numbers. So we need to populate the list with the remaining n minus 2 Fibonacci numbers. So n minus 2 plus the 2 we already have, that will be the n numbers that we want. Okay, how do we append to the list? Well, we need to append the previous one and the one before that. Okay, so just a little note on list indexing. So fib list 0 gives the first element, and then fib list minus 1 gives the last element. Okay, so minus 1, you can think of having a list, and then if you count back too far, so you count back to minus 1, it loops back around to the last element. So counting back too far will loop around to the end of the list. So you can think of the list as like a chain made into a loop. If you count forwards, you go through the list forwards. If you count backwards and you go to negative numbers, so -1, you end up at the back of the list. And then again, -2, you again move backwards through the list from the back. So just as a note, negative index means count from the back of the list. Okay, so that can be quite useful sometimes. Okay, and then we just apply the Fibonacci rule. So the previous one, so -1, plus the previous one, so -2. And then we add that to the list. And if we do this some number of times, we will build up the Fibonacci sequence. Okay, so that is one way to do it using lists. That's perfectly fine if you want to do it this way. Here is another way to do it. So this way doesn't use lists. So we define F1 to be 0. We define F2 to be 1. So that is the first and the second Fibonacci number. We print them, so F1 and F2. And then we do the same, we do a similar thing to before. We go through the next n-2 numbers because we already have the first two. So we have n-2 to go. So we calculate F3 as F2, which is the previous one to F3, plus F1, which is the previous one to F3. And that is our new Fibonacci number, F3. Then once we've done that, we say F1 is equal to F2. In other words, we move F1 1 unit forward. So F1 now takes the value F2, and F2 takes the value F3. So we advance everything by 1 place. Okay, which is what we typically think of with the Fibonacci numbers. We have the first plus the second gives us the third. And then if we want to calculate the next one, it will be the second plus the third gives you the fourth. So there's this moving ahead, okay, with F and F next. Okay, but if you don't like this way and you prefer the list way, that's perfectly fine as well. Okay, so either way, that's perfectly fine. Or maybe you have your own method. Okay, that should be fine as well. Okay, so that is all the exercises that I'm going to go through. All of the solutions will be available on the course webpage, so you can have a look at those. If you have any questions, you can email me. You've got my email on the web pages, on the course webpage as well. And you're always welcome to meet me in my office if you have any questions as well. Okay, I should be in my office for most of the day. Okay, so I will see you next time, where we will start with vector spaces and matrices and a short review of what you should have covered last year in Math 140. Okay, then we'll start with the new stuff. Okay, I'll see you then.